Alright, this is the last section of this particular chapter, section 6.4, and then we will cruise on into chapter 7, which is very short in its own right. Alright, so assessing normality. How normal is something? Is it normally distributed? Normal probability plots. That's what we're going to be talking about in this particular section. So for normal distributions, if the variable is normally distributed, then a histogram of the observations should be good enough to tell you that. That should be of. A histogram of the observations should be roughly bell-shaped if it's normally distributed for large samples. For very large samples, even small departures from a bell shape should cast doubt on normality because the sample is so large. The larger the sample, the better. You can tell it's more normally distributed that way. But for small samples, it may be even difficult for you to even determine normality unless you have some other technique like the normal probability plot. And this is what a normal probability plot basically is this. It's a plot of the observed values versus the normal scores. The normal scores are your scores that we get from standard normal distributions, your z-scores, okay? So basically we're going to plot those on an x-y axis, and if the plot comes out linear, well, it's normally distributed, approximately. If it does not come out roughly linear, you can assume that it's approximately not normally distributed. Now, you should, for the smaller the sample, the more loose you can be on that guideline, but usually it's very strict for large samples. So let's look at an example. Alright, so the Internal Revenue Service publishes data on federal income tax returns and statistics of income. A simple random sample of 12 returns from last year revealed the adjusted gross incomes in thousands of dollars shown in Table 6.3. Construct a normal probability plot for these data and use the plot to assess the normality of adjusted gross incomes. Alright, so first things first. Take your values, and we're gonna have a T-chart. We're gonna have, I'm gonna call it AGI, adjusted gross income, and then you're gonna have your NS, your normal score. Okay, so we need to put these adjusted gross incomes in order. Okay, numerical order. So 7.8, 9.7, 10.6, 12.7, 12.8, 18.1, 21.2, 33.0, 43.5, 51.1, 81.4, and 93.1. Alright, so once you get them in order, count how many you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 here. And we're going to say that that is N. Now, here's what I need you to do. Turn to Appendix A in the back of your book. Turn to Appendix A in the back of your book. And what you want to look at is we want to look at table number 3. Table number 3. So pause the video, get your book. You're going to need it for this, okay? So table number 3. And this is the normal probability table, normal score table, I should say. And so here's what we're going to do. Whatever your N is, locate it across the top. Well, N is 12. Now, under 12, you should see negative 1.64. Well, that's the value of position 1. If you look all the way to the left side of the page there, you'll see that's the value of the object in position 1. So what that means is 7.8 has a normal score of negative 1.64. 9.7 has a normal score of negative 1.11 because that's position 2. And then you can you follow it on down and you will get all 12 positions labeled out there with their normal scores. So if you do that, you should have the next one should be negative 0.79, negative 0.53, negative 0.31, negative 0.10, 0.10. Then we should have 0.31, excuse me. We should have 0.53, 0.79, 1.11, and 1.64. Alright, so this is your X, Y T-chart. So go ahead and draw your T-chart. Your normal scores will be on the Y-axis, your associated gross income on the X-axis. And so we're going to use a break to represent this graph because if you remember, we're going to go negative 3, negative 2, negative 1. And that's why we have to have the break because this is not really distributed. Because if you think about this as a first quadrant graph, you're going to really mess yourself up. Don't think of it as a first quadrant graph. Think of it just as a comparison. And so here's our normal score side. And here is our 20, 30, 40, all the way up to 100, 50, 60, 70, 80, 90, 100. Okay. So plot your points. And so if you plot all these points, it should look something like this. I'm not going to do them exactly. I'm just going to give you a roundabout estimate of what the graph should look like. Okay? It's going to be something like this. There's an exact picture of it on page 269. But if you want to plot these points, I'm not going to do it just because of the time of the video. I don't want to stretch out that time all the way to 30 or 40 minutes plotting points. But you would just 7.8 up to negative 1.64. So there shouldn't be anything below. There shouldn't be anything below negative 2 if negative 1.64 is the lowest. All right, so but notice there is a curve there. If you look at it in your book, you'll definitely be able to see it. There's a curve there. It's not linear. So what we would say is that AGI is not normally distributed. Approximately, it's not normally distributed because our curve is not normally distributed. So if we wanted to do this correctly, I feel bad. You can look at it in your book, but if you want to do this correctly, it's going to be 7.8 negative 1.64, 9.7 negative 1.11, 10.6 negative 0.79. It's going to be 12.7 0.53, negative 0.53, 12.8 negative 0.31, 18.1 is going to be negative 0.10, and then you're going to have 21.2 as 0.10. You're going to have 33 as 0.31. You're going to have 43.5 as 0.53. you're going to have, well, actually, it should be more out here. Sorry about that. And then you should have 51.1 is 0.79, so it should be a little closer to 1. Then you should have 81.4 as 1.11, and 93.1 is 1.64. So, as you can see, it's curved, it's not linear. So, proving that this whole thing is not normally distributed. So, not normally distributed. Okay? So, it's not normally distributed. Alright, so hopefully you understand that, and by plotting the points, finding the values off the T-chart, off the table in the back of the book, shouldn't be that bad. And there are some problems that when you do this, if we were to do the same process for this particular problem, we're not going to work this one all the way out, but if you did the same process for this problem, let's suppose our graph came out to look like this. Let's suppose we had our graph and we had normal scores here, and this is chicken consumption here. Okay, let's suppose we had, I mean, it is a nice line here. I mean, a nice line. So looking at that right there, we would say it's normally distributed. The normality is good. It's normally distributed. Okay, but what happens if we have a dot way over here? That might represent this one right here. This is 0. Notice all the other ones are close together, but the 0 is way over here. Well, what happens if we have that? Well, this right here, just like we studied earlier in our semester, is an outlier. Notice if we took that away, we would have a normally distributed graph. It is a straight line, normally distributed. And we would say, you know, it's plausible that among people who eat chicken, that their consuming of it is normally distributed. We could say that if we took that outlier away. Now, what are some reasons for that outlier being there? Well, I mean, it varies on you're sampling people. So, I mean, you could have a person that is a vegetarian in the samples, and that might cause it to be an outlier. You could someone not to eating chicken. It also might be a sampling error on the person doing the sampling. So, even though we didn't work this all the way out, and this would be a good one for you to work out in terms of practice. This one is actually in your book, so it would be good for you to work out just like we did the last problem. Put all of these in order. Put all of these values in order. Use table 3 in the back to get your normal scores. Plot them and look at it and see what I'm talking about. If you took, there would be an outlier. If you took the outlier away, we would be normally distributed because we would have a linear graph. Okay, so if you run into any outliers, that may be why, and you can be normally distributed with that outlier there. We just say it's plausible, okay, for it to be normally distributed. Since there appears to be an outlier, then it is plausible. We can't say anything without a doubt unless we had all the data and all the facts behind it. But we can say that it's plausible that it is normally distributed. All right, so use table 3 in the back of the book. If you have any questions, please ask your instructor.